Hi, mathletes. Welcome to week 8 of remote learning. I'm going to be honest, this is my favorite unit. Trigonometry is my favorite unit in geometry. So the last 6 classes, we are going to take a look at trigonometry. This week, there's going to be 2 screencasts. So our first day, we're just going to cover the basic definition of what trigonometry is, what does it study, and then what are those 3 trig ratios. On Thursday this week, we're going to go a little bit deeper and we'll actually use trigonometry to find missing side lengths. Next week, we're going to practice everything. And then in our final week, we'll take a look at how you use trig to find missing angles. So we're truly in the home stretch. So make sure you finish the year strong. What is trigonometry? Well, it deals with triangles. The word trigonometry actually comes from the Greek words trigon, meaning no big surprise here, triangle, and metron, meaning something like to measure. So we're measuring triangles. Trigonometry is all about figuring out clever ways to measure and calculate the properties of the components of triangles. Namely, how do you find those 3 side lengths and the 3 angles? In a right triangle, there are ratios that we can use to determine side lengths. The 3 ratios that we will study are sine, cosine, and tangent. Now make sure that you practice saying these out loud because it's very common for people to mispronounce these words. Sine, cosine, tangent. The number one mistake that I'll hear kids say is they'll pronounce this as sin. No, in math, this is sine. Sine, cosine, tangent. Now there's actually 6 trig ratios, but in geometry, we only take a look at the first 3. If you plan on studying pre-calculus your senior year, or maybe later after high school, then you'll learn a lot more about trigonometry. At MHS, the first semester of pre-cal is all trigonometry. So there is much more to this story. In the 6 classes that I have with you, we're just going to cover the basics. Here are those trig ratios that I just mentioned. Sine, cosine, tangent. So keep practicing saying them out loud. Sine, cosine, tangent. Now you'll also see this funky looking symbol after those 3 trig ratios. This is the Greek letter theta. Pretty much is a placeholder for that missing angle or the angle that you're working on in the triangle. So theta in our triangle is right here. Now there's 3 vocab words that you can label the 3 sides with, and it all depends upon what angle you're working off of. Now, because it's a right triangle, my hypotenuse has to be the side across from the right angle. So the first thing that I always do is I label my hypotenuse. The second thing is I might physically even just put my finger, so pretend the cursor is your finger, and put your finger right on the angle that you're working with. So this is the angle that I'm working with. If you touch the angle, you're also touching the adjacent side. Adjacent means next to. So it's the side that's next to the angle that you're working with. And since I already know that this side's the hypotenuse, this other side has to be the adjacent side. An opposite is the side opposite the angle that you're working with. So this side length is opposite the angle theta. Now these are the definitions of your trig ratios. Sine of angle theta is always the ratio of the opposite side length over the hypotenuse. Cosine is always the adjacent side length over the hypotenuse. And tangent is always the opposite side length over the adjacent side length. Now, there's a mnemonic device that a lot of students use to help them remember how to set up these trig ratios. And that little mnemonic memory trick is SOHCAHTOA. It's not really a real word, but it kind of helps people remember how to set them up. So SOHCAHTOA. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent side. So SOHCAHTOA. Now, when I write SOHCAHTOA, I always like to kind of write it like this. I like to write it with the ratios built in. And so you can decide which way is easier for you to set up. But SOHCAHTOA is kind of your trick to remembering how to set up these ratios. Example number 1, find the sine, cosine, and tangent for angle A. Now it's really important that you know what angle in the triangle you're working off of. So angle A, this is my angle. The first thing that I want to do is I want to label the hypotenuse. I want to label the side that's opposite angle A, and I want to label the side length that is adjacent to angle A. So one thing I would recommend is whatever angle you're working off of, either put your finger on it or maybe like circle it, darken it so that your eye goes to that angle in the triangle. And the next thing is label those side lengths. Now you can write an H for the hypotenuse on that side length that's across from the right angle. If you touch the angle, so pretend my cursor is my finger. If I put my finger on the angle, I'm touching the adjacent side. So that's how I know that this is that adjacent side. Adjacent means next to. So it's the side that connects and is next to the angle. There's only one side length left, and it's that opposite side. So it's the side that's not touching the angle at all. And you can label the opposite side with an O. Sine of angle A is the opposite over the hypotenuse. Remember our mnemonic device, SOHCAHTOA? So sine is the opposite over the hypotenuse. Now, if you labeled it, it kind of makes it a lot quicker. Opposite side was 8, hypotenuse was 17. Now, this is the exact answer. If I type 8 divided by 17 into my calculator, there's what it is approximately as a decimal. But you'll be using your ratios, so you'll be leaving them as the fraction. Cosine of angle A. Cosine, by definition, is the adjacent over the hypotenuse. My adjacent side is 15, and my hypotenuse is 17. So when I set up my ratio, I'll have 15 over 17. And if I want it what it was approximately, then I could type in 15 divided by 17, and that's how I get that fraction. Tangent of angle A. Tangent, by definition, that ratio is always the opposite over the adjacent side length. My opposite side length was 8, and my adjacent side length was 15. Again, if they asked for the approximate value, I could just enter that into my calculator. So 8 divided by 15, and that's where I'm getting these decimals from. But again, what you see in purple, that's how you're setting up your ratios right here. All right, if you want to try this one here, you can pause the video right now. If you want me to go through it, then don't pause and just listen to as I go through this next one. Find the sine, cosine, and tangent for angle B. So again, it really matters what angle you're working off of. So I'm going to circle angle B. And the next thing, you want to label those side lengths. What side length is the hypotenuse? What side length is adjacent to angle B? And what side length is opposite angle B? So my hypotenuse is that side across from the right angle. If I touch the angle, so if I put my finger right on angle B, so pretend my cursor here is my finger, I'm touching the adjacent side. So that means that 8 is the adjacent side. And there's only one side length left, the opposite side. And the side that's opposite is going to be that side length that does not touch the angle at all. Sine of angle B, by definition, sine is the opposite over the hypotenuse. My opposite side I have labeled, so it's very quick to fill in. And then the hypotenuse I also have labeled. Cosine of angle B, by definition, cosine is the adjacent side over the hypotenuse. And the last trig ratio, tangent of angle B, by definition, my tangent ratio is always the opposite side to that angle over the adjacent side to that angle. So opposite over adjacent, I'll have 15/8. So that's how you just set up your trig ratios. That's our goal today, to just get the trig ratios down and to be able to set up the ratios. That's your goal today. So if you already feel confident, then you're on your way to meeting today's goal. This is if we were doing this in class, one of the biggest things that people usually have questions about, or they're usually confused with about, is the difference between opposite and adjacent. So it really matters what angle you're working off of. So look down here. If this is the angle that you're working off of, if you touch the angle, so I'm going to put my cursor on the angle, you're touching the adjacent side length. I already know that this has to be the hypotenuse because it's across from the right angle. And over here, if you touch the angle, you're touching the adjacent side length. So that's one trick that you can use to kind of figure out adjacent versus opposite. Adjacent means next to, so it's the side length that's next to that angle. Example number 2, use the triangle to write each trig ratio for angle P. So again, they have to tell you what angle you're working off of. This is angle P. So I always like to either circle it or I'll put my finger on it. Next thing, I'm going to label those side lengths. What side length is the hypotenuse? Well, it's the side length across from the right angle. If you touch the angle, you're touching the adjacent side. So this has to be the adjacent side. It's next to angle P. And that third side is the opposite side. So it's the side length opposite the angle. If I'm trying to find, this should have said sine of angle P. I don't know where it went. I don't know what happened there, but you can figure it out. So sine of angle P, the directions just want the ratio. So I think back to that mnemonic device. Sine is the opposite side over the hypotenuse. But remember, when you write your ratios, you do want to make sure that they're simplified. So 6/10 is a fraction that can be simplified. So my simplified ratio would be 3/5. Cosine of angle P. If you want to try these on your own, you can pause the video right now. If not, you can continue on and listen. Cosine of angle P. By definition, cosine is the adjacent side over the hypotenuse. So again, set up your ratio. If you can simplify your fraction, then definitely you want to simplify it. So my final answer would be 4/5. My last ratio is tangent of angle P. Tangent, by definition, is the opposite over the adjacent side length. Set up your ratio, investigate it. Can you simplify it? And this one, you can simplify it. So your ratio is 3/4. All right, why don't you try these on your own? So number 1, all you want to find is cosine of angle A. You're just finding one ratio. You're just doing cosine of angle A. And on number 2, all you want to do is set up the ratio for tangent of angle X. So I'll hit the timer. I'll give you 60 seconds. So try those 2 problems, and then we'll see if you got them correct. Let's see how you guys did. For number 1, cosine of angle A, first thing I like to do is kind of draw attention to the angle that I'm working off of. because that makes a huge difference. I label my three sides, so the hypotenuse, the adjacent side to that angle, and then the opposite side to that angle. And cosine is the adjacent over the hypotenuse side length. My adjacent side was 20 and my hypotenuse was 25. Make sure if you can simplify that fraction that you simplify it. So if you got 4/5 for number 1, awesome job. On number 2, tangent of angle x. Again, I like to draw attention to the acute angle that I'm working off of. That makes a huge difference in how you set up your ratios. I label the hypotenuse, the adjacent side, and the opposite side. I think about the tangent ratio, and it is the opposite over the adjacent side length. And again, always make sure your ratios are simplified. So if you got 12/5, awesome job on that. And that is it for today's lesson. So make sure in the module, there's going to be some practice listed. So make sure you complete that practice because having these ratios down is going to make a huge difference in the last 5 classes. And it will just make the last 5 classes a lot easier for you. I hope you have a wonderful day, guys, and I'll see you on Thursday.